Okay, everybody, welcome back. Let's get started. So we're going to do fun stuff today. We're going to look at the graphic interface for the iPhone and for the iPad. I know a lot of you guys are a little bit overwhelmed with the Objective-C programming. And for those of you who are not also concurrently taking the Objective-C programming course, I highly recommend you watch the videos. The class happens right before this class, and I record all of the lectures, and it's almost as if you're taking the class. And if you're not taking the class, don't worry about it. You can still watch the videos. They're on YouTube. And there's also, if you go into the link here, which will also help you guys. Actually, let me just open up a new window here. If you go into the bhacker.com website and you go into the class for the Objective-C programming course, and you click right here on the Apple's Objective-C guide. It's 106 pages. It's a book written by Apple, all in the Objective-C language. It's the book I'm using, or the text I'm using. In fact, I'll just do it here. Let's just save it. Save it to the desktop and open it up and show you what I'm talking about. It's 106 pages. And then what I like about it is, outside of of it being written by Apple, which is excellent, it's a very easy read. And not only that, but you can click on stuff like, let's look at ID as an example. I click on it, it takes me to the ID. I mean, what is ID? So you can actually kind of search through this stuff too. You could search through the document. Let's say go here, property, and takes me to property here, property declaration. Property declaration, here's properties, attribute, type, name, and it kind of explains what everything is. Because it's really hard to do any programming in this environment without having an Objective-C kind of background, without taking that class. It's really hard to get what you need. In fact, just today I've had students who took the iPhone class in the past who are now taking, in reverse order, now taking the Object-Oriented Programming in Objective-C class right now. And she's all of a sudden, like today, light bulb went on. She said, "Oh, I know, I understand what properties are." I say, how in the world did you make it through the iPhone class without knowing what a property was? For those of you who don't know what properties are, watch the video. I just explained them in like almost 45 minutes of detail just a few minutes ago. So watch that video. It comes in pretty clear because it's recorded on my computer, so it should hopefully be understandable. And it's the background you need for this class, actually. But fortunately for you, I'm teaching it at the same time. So just because you're not enrolled in it doesn't necessarily mean you can't benefit from it. So you can still watch the lectures and you can still participate in this class and still be able to do stuff and still be effective without having to just stress about the programming part. Because as I mentioned last time, iPhone stuff is pretty easy. It's the programming part that's pretty hard. It's pretty difficult. So unfortunately, if you don't have the background, you kind of need to sort of follow both classes. Watch the videos if you really want to learn. In fact, you only have to watch it to a certain point because you don't need that much Objective-C programming. In fact, you could probably go for the next couple weeks, watch the videos from the start, from Hello World, all the way through classes, and then you're pretty much done. You don't need to know the rest of that Objective-C because you don't need to know about the Coca interface for the Mac, which is what I'm going to get into later. All you have to know about is the first couple weeks of that class, because that's what you're going to use for the iPhone. And this is what you're going to use for the iPhone in terms of the graphics libraries and the graphic objects. So today we're going to talk about graphics, graphical user interface, and how it applies towards iPhone, iPad development for iOS. So we know that Coca is the class library, hopefully, and we know that the Coca Touch is the interface. So if you go into Xcode, you probably have accidentally clicked on Coca instead of Coca Touch, maybe. It's actually kind of easy to do because there's two separate sections. In fact, if you look at Xcode as an example here, I'm like, why don't you just show you what I'm talking about? If I go and open up Xcode, I can see, actually let me just go in here, I can see on the application part of it, let's just go here next. I'll just type in something here. I'm just going to create a generic project. Now I have this junk project on my desktop. If I go File, New, File, this is what I'm talking about. So we can take and create an Objective-C class that works with Coca Touch for the iOS or that works with Coca, or that works with C++, or we have user interfaces. We have all sorts of different things that we can do on the Mac end. That's what you don't need to know out of the OS, out of the operating system, out of the Objective-C class. This stuff is what I'm going to get into as soon as I cover the base language. But for your purposes, you're looking at Coca Touch, which is the interface. So if I go Coca Touch and I click on the Objective-C class to create one, I'm going to get Coca Touch interface objects. As an example here, I have UI table view controller. We actually saw that in a couple examples already. App Delegate. I'm going to talk about App Delegate and stuff like that soon. OpenGL, CI color, CImage, all these different classes in here, arrays, NSApplication. This is what I'm talking about today. All the NS objects for all of the Coca Touch interface components that you're actually using to create iOS applications. There is a little bit of an overlap with macOS X because it's all Coca. Some of it's from Touch and some of it's native Coca. So I'm going to quit out of here. I have a slight allergy problem today, so if I clear my nose too much, let's just cancel this. I'm just trying to get out of here. There we go. Alright, so we know about the Coca class library. That's what I'm talking about. It's the inheritance. It's all written in C because Objective-C is a dialect of C. So it's all base C language. So it provides the classes for creating applications with GUIs and graphics and capabilities. We can also use OpenGL for graphics because the Coca Touch is actually, there's an OpenGL component to it. I will probably talk about OpenGL way late in the course. But know that that's kind of one of the options you can do. If you're, okay, so you're going to program a game, and the game is going to be heavy graphic intense. The library only takes you so far. So common shapes, common components for common everyday applications are going to be in the Coca Touch interface. For, you know, really nice three-dimensional something, you're going to need OpenGL. Or for a really nice graphic rendering for something, for some odd shape or the ability to create a wireframe of something, you're going to need OpenGL. So usually for specialized gaming, heavy graphic, normal everyday iPhone application development, no, never going to touch it. There's some people who have never touched it at all. Not necessarily a requirement. OpenGL is written in C. So you have C interface as well to the Coca Touch in terms of your capabilities. Creating applications for the Mac are done the same way as creating applications for the iPhone, believe it or not. So we have that same kind of concept. So essentials of graphics. We have the event loop, which is the graphic events that are occurring. We have mostly important classes that are part of this event loop, and this is where we get, and this is actually for the people in the Objective-C course. We're going to hit this in terms of, you know, we're doing command line right now. Eventually we're going to get past the command line, and we're going to want to create an application. Well, then we, instead of extending from, you know, an NS object, you know, or maybe, you know, for depending upon what we're trying to do, we can extend from NSApplication, which is sort of like if you've taken the Java course, it's sort of like using the Swing libraries. So in Swing we had, we had JWindow, JFrame, you know, we had our AWT, you know, library had different components as well, you know. So NS is everything that starts with the next step for in terms of the operating system interface. NSApplication is the application itself as an object. The window is the frame or the window itself. Responder is the event listener. The view is the well, we've seen views actually already in the view controller. The view is the canvas. And then we have the button, and we've seen an NSButton as well. We put some NSButtons out there. We've put some NSViews out there. When we create an iPhone or an iPad application, the storyboard is giving us the application. We don't actually have to worry about the first three. We work on an iPhone or iPad, we work with views and we work with buttons, and then we have, and that's just an example, there's tons of other things in here as well. This is just a short list of components. These are the most useful ones, however. There's, you know, UI labels, and what we get is a whole set of UI for user interface. All programming depends heavily on the usage of object-oriented principles, using Coca classes, derivations, and overriding of methods. So we override the methods of the built-in classes to get the functionality that we want. We override things to, as an example, we've seen the touch up, the touch inside. For a button, we're really overriding the method. When we implement our own method that we know, remember when we dragged over from the UI button and we put it into the interface, and then we implemented it in the implementation file. Maybe this ringing some bells, I don't know. But long story short, we overrode the method for touch up inside or long touch or whatever. I don't know. There's no such thing as a long touch, but you know what I mean. It's like one of the methods that is associated with the object, the NSButton, as an example. So NSApplication. This class represents the event loop. We see this with the macOS X. We see this with Mac applications. We don't really see this. We see instead we have the app life cycle that we deal with on the iPhone or the Android. So we're never going to create an application that's given for us already in the project type. However, the application does start, and we can ruin the application depending upon what we've got set to run first in terms of the GUI. But the concept of the NSApplication gives us that main event loop that's occurring, creates the loop, starts the loop, and stops the loop. The window initializes the window or the component with various different Windows parameters. So the same technique that we're using, we can actually use it for macOS X development. The structure of the window, the frame, the content of the window. So we have the window concept because if you remember the tab view controller in the demo, tab view demo, and then one of the samples we went over on Monday or maybe last week, we dragged and we put a controller inside of the window. And the window was I call it a frame, but it's a really window that's inside of the view that's being used to control and controlled by the application, and the application had a controller, and the controller controlled many different views. In fact, the tab view had about 3 different views to it, if you remember that. NSWindow is actually the component. We have this thing called a callback. So callbacks, these are methods that are not called through the code of the programmers, but through the events created by the user of the application or by the runtime system. So when we ran the web view, we had an automatic callback that occurred that, as soon as, because we set the web view as the main view, and we set the view to open up a URL. And so that was an automatic event that occurred when the window opened to load the URL, which is part of event-driven programming, and it's essentially what you've been familiar with so far. It's just terminology is being used. They call it a callback. All callbacks are provided through the class NSResponder. You can actually write to the responder and change the callback behavior. So something else happens, or maybe you put a delay on it, or you customize the behavior. And that responds to the superclasses for the NSWindow and the NSView. So we have the ability to kind of manipulate all of that stuff through the overriding of the methods that are associated with each one of those objects in the hierarchy. Callbacks are added to the program by ultimately deriving from NSResponder, overriding the inherited callback method, and then using a derived class in the code. So basically adding your customized method to change. So when the user clicks on a button, it does something differently or something, or I don't know, goes away, disappears, or the screen responds differently, which is the NSResponder that's actually being used in that particular context. So that was number 8. These are really short lectures, by the way, and as you can see. Number 9, we're going over 8, 9, and 10 tonight. This one's a little bit, well, it's the same length, about the same length. Those are the main object components of the GUI and sort of your introduction to the GUI interface. We'll look at windows, views, and buttons in a little bit more detail in this lecture, which is lecture number 9. So we have the NSWindow. So every graphic application needs at least one window, which is why when we load it up, we get one XIB. And XIB is our window. So whether we use a storyboard or not, we're still going to get a single window view. We could have different types of window views. In fact, the different project types now have like a tab view kind of, default, and We'll go through some of those different project types, but they're basically holding up at least one single view. You cannot draw in Windows, but they can draw in views. So you can't draw in a window, but you can draw in a view that sits inside of a window. So windows hold the views, and the window contains a content view, as we've seen. So we can add subviews to the content view. Content view, in our tabbed example, we had a list. We had a, I can't remember what it was, a tab. We had a tab controller, a tab view, no, excuse me, we put a tab view inside of one of the content view of one of the windows, and we had like a list that showed up in the window, and we pressed on it and said this is item number 1, this is item number 2, if you remember that example. We nested it is what we did, and we dragged and dropped something inside of the view to change the content of what appeared in the view. So NSViews, a view can be put in a window by means of a content view. So a view can have many number of subviews. So it's in a hierarchy, kind of like the Android actually, but the Android calls it a layout. Well, layouts and views are similar, but they're not exactly the same. A view actually has more components and more properties to it, and does more. So a view can have many other subviews associated with it. A subview of a view will never extend beyond the range of the superview. The hierarchy is a single line hierarchy inside of the view. You can't hop from one view to another view. So when you design your application, you're going to bring up a view, and that view is going to have a subview and a subview and a subview or something associated with it. You're going to go up and down within that hierarchy, and then you're going to switch windows, or you're going to switch views in order to get to something different. So views are siblings, should not overlap, because the sequence in which siblings are displayed is undetermined. So if they're overlapping or using each other, you can't actually predict what the user is going to do, and the user might actually, not load one or something, or there might be issues with that. So it is restricted. The hierarchy is within the views. NSButtons. NSButton is derived from NSView, and it inherits all of the methods from NSView. Can be added to a view, can be initialized like a view. Actually, it kind of works like a view. Actually, the buttons are pretty powerful. Special methods for initializing buttons. There's special ways of adding callbacks to buttons. So we have target action design pattern. So remember IB action. So we have IB buttons with IB actions that are associated with the buttons. And some of the actions are the touch up inside, touch in, double touch, I don't know, the different X go into the little screen that you get when you right mouse click on it, and you'll see all the different button activities. And those are events. This is an event-driven programming environment, so the code has to respond to what the user is doing. So each one of the objects is an example, the button, which has all those different properties associated with it, with all those different events. Well, you have to program all those different events, because if the user does, program the ones you want the user to use. Otherwise, the user could left mouse click or right mouse click, I don't know, or do something to it, and there's no event associated with it, nothing's going to happen. Your program's going to look like it doesn't work or something. So you have to be careful to make sure you implement the right behavior for the right button, the right control that's being actually performed on the button, the right type of touch. With that concept in mind, you can actually do that to views as well. To scroll a page, when you stick your finger on the background, a long press to bring up a context menu, sort of like the Android environment. Scrolling left, right, up and down, all those things can be put in terms of the properties that are set. So we can speed up the scroll, slow down the scroll, flip the pages instead of going, from basically creating some special events that occur. NSResponder. NSWindow, NSView, NSApplication are all derived from NSResponder. So as the object component contains all the important events, messages, and that your application actually needs. This is where the events are actually coming into. It's sort of automated in the iPhone environment. We don't actually, the NSResponder is back there, but we're not actually making any calls to it. We could, but the normal GUI interface to it, we're just kind of working with it. We're extending from that library but we're not really, I mean, we're overriding behavior for it, but we're not really making instances of this object or using it, where it's kind of implemented by the components that we're using. So we make our application respond to these events by overriding inherited event messages. Event messages are the actions that are occurring. Application Delegate, app delegates. So when we make an application, we get this set of files. It's called app delegates. I'm sure you've seen them. If you wish, you can write a class that implements the NSApplication Delegate protocol. So if you add an object to this class as a delegate to the NSApplication, then the implemented method will be called at the certain point during running of the program, during running of the application. So you can do anything you wish in these methods. Actually, you can use these for anything you want. So the application delegate actually can be part of other classes in terms of implementation as a method to delegate. You can actually put things in a separate class for the app delegate classes. So they can serve many different purposes to structure or program the code and customize the behavior of the application. Usually, if it doesn't belong in a controller, then you're going to put it in the app delegate classes probably. You're going to put data definitions. If you were creating, let's say, a list of something, that might go in there. There's basically the catch-all data kind of stuff as well. It goes sort of in there as well. In terms of the target action pattern, we've sort of seen this with the IB action and IB outlets. So interface button outlet, interface button action is associated with it. That's the target action pattern. So in the interface, we say this is the target, and in the implementation, we say this is the action that we're going to perform on this target. And we've seen that actually in a couple of different examples so far. The pattern makes Coca graphics programming very easy and powerful. So when we put our component out on the canvas or the window, we drag it to the interface, we create the target, and then we flip over to the M file, and then we create the action that's associated with it. So for a button as an example, that's where we actually assign the behavior associated with the button controls, the button events that occur when the button is actually pressed. So action targets can be changed dynamically at runtime. Yeah, actually, depending upon what the user is doing, the action on the target is going to be different, perhaps, if it's programmed that way. Programming examples in the lecture will make this clear. We're going to see a lot more programming examples that will show you the relationship between the targets and the actions. So, right, so let's see the buttons and the components and things and see how that relates. So look at the interface builder. So let's see. So this is number 10. So what do we have here? The user interface builder, IB interface builder, XIB, Xcode interface builder. So you start Xcode, you choose a new Xcode project, you choose MacOS X application, or you choose iOS application, you have your choices. You can choose an icon for the application, either way. It's going to basically have different properties for it. The name for the application, you can set its location actually, the window location, where it shows up if it's a Mac application. If it's a iPhone or iPad application, you're working with the default settings for that particular environment, for which you can change in the properties window. A lot of people don't realize it. Let me bring up Xcode one more time here actually. I should have just left that project up. Here actually, wait a minute, I have got that project right here. It's the project with the weird name. When you bring it up, you see in the middle, which we haven't actually looked at yet, when you see this up here, you've got the info for the project. This is for the application. So in here on the summary, we can set the application icon. So all of the controls are actually in the middle. When you click on over here on the left-hand side on the default project, these are the project settings. So your build information, your build phases, your build rules. In here we can set the framework. In fact, we have the linked framework libraries that are showing here, and we have Coca framework that's actually in here, which is required. We can go into build settings and change, well, if I don't like the name of my application, I can change the product name, things of that nature. But for the most part, this is our interface to the application object. So this is the NSApplication. in terms of the iPhone, iPad environment. We're not really going to play around with it very much for this particular class. Where you're going to find it helpful is when you're trying to link libraries. As an example here, if I've gotten the link libraries here, my default is going to be the Coca interface. If I press on plus and type in, I don't know, what library would I want? Audio. I've got audio libraries, core audio frameworks, and things for different features of different apps that I'm going to load in. So this is how I'm going to actually include packages, I'm going to call them our libraries, into the actual application that I'm going to work with. And actually I can drag an icon, believe it or not, and stick it in here by taking it from the desktop as an example. This is not going to work because this is not an icon, but I would drag it in and, oh, actually it worked. Kind of weird. This is that downloaded PDF file from the Apple site. Actually kind of see it says Objective-C programming. Well, that's going to give me a strange icon that's going to share. Maybe it just takes a picture of that. I don't know. But our main interface is just going to be the main menu. I can actually change the main interface if I had multiple different interfaces defined in here. I can actually change that around. We know already that if we're using a storyboard, actually, here's our app delegate. In fact, this particular project isn't using a storyboard, so it actually has the main menu.xib. And the main menu.xib is going to be, oh, actually, you know what? I created a 64-bit map application, which is interesting. So this is not even an iPhone app. This is a 64-bit Mac, which is interesting. And I can see my frameworks, and I can see all of the components for the project over here. I can modify the project setting. Well, basically this is an interface to the object properties. So if I were doing this at a command line prompt, which I could do, write a command line console application that loaded up objects, I can just run the properties and set the properties of the application, of the window, of all of the different things, kind of like the way we do, if you've ever worked with the swing libraries, if you've ever written a command line. Well, if you were in the Java course, you wrote a Notepad application. The Notepad application you wrote with a command line prompt, or you used a non-GUI editor for it. You can do the same thing as what I'm trying to tell you in Xcode. So I'm going to close that down, actually. All right, so let me go back to this lecture. Oops. Clicking too much today. Here we go. All right, so those are the components. These are the basic starting sequence is to load up the project, set the properties, put an icon in there, do a bunch of stuff, save it, save the IDE window. So the minimal application we just saw a few minutes ago had main.menu.xib, and as we mentioned before, XIB stands for Interface Builder, Xcode. So we actually just saw that a few minutes ago. So the minimum application represents the Xcode IDE contains an NSWindow. This is the window component. So say running, you click on build and run. I didn't do that, but you would have seen it running. To start the IAB, you actually just click on it. We've seen this already with the storyboard. So newer releases of this have a storyboard. The storyboard actually has an XIB extension on it. When you double click on it, it brings up the interface builder. And then we're able to manipulate everything inside of it. So the storyboard is nothing more than a blanket housing container for the XIBs, if you want to think of it that way. So the interface builder, or the interface, so upon starting the IB, was presented with the application window at current and how it currently looks. We've seen it before, hopefully. It's the kind of drag components from the library and put it on the canvas. The menu bar for the application is also, everything for the application is actually in the interface builder. We can add, we haven't done it yet, but we can add, well, if you're running, you're not going to put a menu on there unless you're running a non-iPhone app. In fact, I highly recommend actually bringing it up and not select the Mac Mac project type and not the iPhone or iOS. Select the regular Coca interface. And in the interface builder, you'll see there's options. You can drag and put menus on there, drop down menus and things. So you can create an application with it the same way that you're creating iPhone apps, actually, and drag stuff from the library onto the canvas. It's actually kind of the same type of GUI programming, actually, which is kind of nice. So in terms of working with the interface builder, adding GUI items to the window. So you open the libraries we've seen so far, and you drag objects. So the library actually has a couple of different views to it. The object view is the one that's going to give us all of the UI events, UI labels, UI buttons, round rectangular buttons, all those little things that we've been using so far. So from the objects or the classes tab, you can drag various different GUI components and put it on the window, release them, and automatically creates the corresponding GUI object. And then we have dragged the object to the .h file. We can create the entry in the code that meets or matches up with the object that's on the canvas. So an object is not suitable to be in the window, the dragging will simply not work. Actually, that's true. So it's kind of user-friendly in that way, except for it's not going to tell you that it's not suitable. Instead, it's just not going to work. So if I opened up a window and I tried to put something in there that didn't belong, it's basically not going to work. So if you've been doing that and you're dragging stuff in there and it's not working, probably means the item is not suitable for where you're putting it. So if I had an iPhone app and I actually got to, let's say, the menu options and stuff, it's not going to have a drop-down menu like it would on a regular application. So resizing and positioning the GUI, all of the GUI items can be graphically repositioned as we've seen so far, or resized. Can be given a color, certain frames, text, or pictures and things, and we've seen that actually already in terms of the properties on the right-hand side. But just actually, let me open up. But let me give it a real property. Let me give it a real. Let me create an iPhone app. iOS. There we go. Single view. Let's do that one here. I'm going to just put here test app. Let's do this too. Storyboard, okay. So in our storyboard for either our iPad or our iPhone as an example here. Hello, oh, it's still indexing. We'll give it a few minutes here. Most people actually would use the GUI, so if we had our controller, oops, this one here, iPhone. So if we have our, would be considered the NSWindow. The properties for it are going to be on the right hand side. If we clicked on the window itself, we're going to get the view controller properties that come up for the view controller. So I can actually title the window. So my window as an example, and give it an identifier like my win, which means I can use it in the code to say that my window. It'll put my window up here as an example, title for the window. So these are the properties that are associated, and the drawing being opaque, hidden, clear, all of the different, and then the auto resizing. Well, in a regular old iPhone, you can't resize the window. You're stuck with the window sizing. But in a Mac application, you can actually take this thing and drag it, make it bigger. And we know we have objects over here, so we have Coca Touch storyboard with controllers and data views and all sorts of different things as an example here. And when I'm dragging it, you see I can get like an example. So far we've been actually just following through some tutorials and looking at certain items, but there's a lot more in here that we haven't seen yet, which is one of basically. So we have gesture recognitions as an example. I can put this on here. And if it's not appropriate, well, it is because it's loading it up down here. Means when I do this particular, like these three fingers, like in this position here, it's going to do something. And it's kind of like if you've ever played around with a touchpad on the Mac. Most people maybe learn about half of the gestures. These are the gestures it's talking about. Also in here were the data views, as I mentioned before, so you can kind of get like. You can see visually, I'm going to put a data view in here. We got the table view in here. This is going to be an ugly app. But most of all, you're going to go into objects for the most part, and then you're going to use the search for, let's say, UI label or something, or label. And you're going to click on stuff, and you're just going to basically be dragging it. And if it's not appropriate, in fact, in this particular case, oh, it was appropriate. There we go. If it's not, I'm trying to find an inappropriate object actually. Let's see, windows and bars. Well, there's no matches because I have this down here. Hold on. There we go. How about a navigation bar? No, that's appropriate too. How about this guy here? Put this guy in here. Search bar. Put a search bar in here. There we go. Anyway, long story short, if it's not appropriate, it shouldn't drag in, theoretically. So, what's down here? What's this guy here? Search bar with display. This is really a confusing, ugly screen. It should actually work though, if I run it. Of course, my simulator is on the wrong one. Stop it. Just that one instead. We're gonna have a real ugly GUI. But if you haven't done this yet, I highly recommend doing this. Just create a default project and start dragging some stuff over, because that's really going to show you all the differences in terms of the GUIs. That's going to be a real ugly application. If it loads. Yeah, it's going to load. It should load. Okay, well, it's probably not going to load because I have too many things layered on top of themselves. But anyway. So let me go back to this real quick here. So all of the GUI items themselves can be graphically repositioned. And you can text and type in them. You can save the additions and the changes in the interface builder by pressing on the command, which is what this little symbol does. Command S to save it, or you can actually just use the menu to save it. It does actually auto-save in the current version of Xcode as well. You can quit Xcode. Well, you can't quit the XIB. You can't quit the interface builder. In the old versions, the interface builder came up as a second component, as a secondary thing. Now it's integrated into the environment. So you just basically click on something else and it's still running in the background. So adding behaviors to the GUI items themselves, which is kind of the important part of the event-driven behavior component. After you drag it on there, we've seen how you connect it to the interface. Now in the implementation, you would basically create the behavior. All GUI items have predetermined behavior corresponding to the item. As an example, a text field will allow text to be typed into it and be changed and edited, and a button will change the color upon being checked or something. So color buttons change colors, text boxes allow you to type stuff in there, buttons allow some click events. You can always want to we always want additional behavior that's determined by the logic of the application as well. So for example, a text typed into text fields should be analyzed in the program code, and then certain actions should follow perhaps, or clicked on a button should start some other action in the application. So you basically need to do a couple of things to kind of coordinate the behavior. So you must, in your code, have references to the GUI, which you intended to trigger by the action in your code, and the data that you want to use for that particular action, which is where this action sort of thing comes from. So the outlet is the object, the action is the behavior that's going to occur when the outlet is actually used. So you must program these actions and set them to be called on when the user event occurs, such as a mouse or typing or something. So how do you establish the reference between the GUI and the action? Well, you can create a reference the same type as the GUI type or item in your code. So if your GUI is a text field, you can create an NS text field object in the code. We haven't actually done this yet, and so far we've been dragging. So if I dragged it over, in this particular case, I've got this project still open, I believe, yes. If I clicked on the editor and I pulled up, oh, no editor screen in here. Well, let's click on this one here. Got too much crap in here, hold on. Let's put it, but well, we've seen it before actually. We drag it over to the source, we create the reference for it, and then we actually create the my view controllers. I messed up, it looks like. Okay, well. Alright, so let's forget that. But so we've seen it actually in some previous examples, so I'm not going to bother going through that again. So we can drag it over. It's like I was trying to show you a few minutes ago, but I've messed up that project because I don't have the right GUIs on there. But the other thing we can do is actually work in the opposite direction. Create in the code instances of, let's say, for example, an NS text field or NS label or something. We can create objects of these labels and then attach them to the GUI in the opposite order. So we can write the application first and then add the GUI second if we wanted to. If we do that, we create an instance of the NSText object in this particular example, and we put it in the code. So where in the code does it go? It must be inside of the class that is known to the interface builder, which is going to be the controller for the XIB file. So this has nothing to do with the GUI item in which the text field is actually graphically located. It has something to do with the controller class. So it's the view controller that's associated with the view that ends up with the code that's associated with it. So for example, you can put in the NSWindow class if you wanted to, because your application doesn't have an NSWindow code. You can actually add code for the NSWindow. You can programmatically change all of the GUI components by the source code and not actually use the interface builder as well, which is kind of interesting. App Delegate class, you can put it in the App Delegate class if you wanted to, because you can see this class listed in the main XIB window. Or you can put it in your class that you make yourself, so you can create your own classes. And we actually saw this with the tab view controller that we saw. We put some extra classes in there and assigned them to the views, so we had that working. So establishing a reference to the GUI item. To continue with the example here, for our application name ABC as a kind of an example, we can place the line IB outlet text field, and we're using this asterisk here, and it's really a pointer to an NS object, which comes from Objective-C, and I actually just looked at this earlier today. So if you're not familiar with the pointer concept, go ahead and go back and look at the lectures for the Objective-C class, especially from today and from Monday of this week. I went over this because this is an NS object. All of the objects are dynamically allocated, and they're created at runtime. Nothing is statically allocated. And because it's dynamically allocated, it has to be in the form of a reference, which is really a pointer to memory. Fortunately for us, we don't actually have to do the alloc on it, but we could. We have some automatic stuff going on now with the current version of Xcode, so we don't really have to go into that much of the memory problem in this class. But the asterisk is basically saying that this is a pointer, and the pointer is TF1 is the name of the object. The type of the object is going to be a text field. In our case, we're going to see UI objects, UI label, UI text field, stuff like that. They're IB outlets in terms of the object type. And this would be sort of the data type, which essentially is where we get this generic IB outlet, which means it's an action interface builder outlet that's going to be associated with an IB action. So this is the GUI component. So we have IB outlet. This is where it comes from, actually. IB stands for interface builder, outlet stands for the component. So this is kind of like ID, actually. It's kind of a generic component. So we can have everything's an outlet, everything's an action, but we have different types of GUI components. So in the ABC App Delegate class, as an example, you can declare the reference, or you can drag it into the interface class of that particular object, the view controller object. Open the inspector window on the connections. The inspector window is that side window with all of the properties and things. One of the tabs is called the inspector tab. In the older versions of Xcode, it was in a different GUI, and so we actually had a window that was called inspector. Instead of a tab, it was like a window control. You can highlight the App Delegate class in the main XIB window, because the reference is then added to the class. In the old days, we actually did it the opposite order. You put the code in, and then you dragged it over to the GUI. Now we take it from the GUI and drag it over to the class, which is different. So the identifier TF1 will show up in a list of outlets for the connection inspector if you're doing it the old-fashioned way. Here's actually what it used to look like. Actually, this is an old slide set with the text box on it. And so this is the same window we have. It's not colored anymore, but it shows up on the right-hand column of our display. We just saw it a few minutes ago in Xcode. So we would see it listed here as outlets, and then we would actually be able to drag, let's say, this to here, and we would make the connection. So nowadays it's actually kind of done. We can actually still do it this way, but it's harder to get to this window than it is just to take the GUI and drag it over into the code itself. So this is the window that's controlling the code, the X file, the .h file. So because the ABC window is a connection inspector before the and after the connection is made, in fact, the people using the older version of Xcode will appreciate this slide because this is what you guys see. Because this here is with the interface builder, it's not integrated on the side. So I actually kind of like that look better in the older version because it was easier to find. But, you know, pros and cons. So you click on the empty circle as an example, you right mouse click, you drag it over to the controller window here, and it makes the connection for you. So basically what we're doing is we're still dragging and dropping by pressing on the control key and then mouse clicking on it and dragging it either to the code or into the inspector window depending upon the version of Xcode that you have, or dragging it in the opposite direction from the inspector to the canvas or to the window. So adding an action. So you can add the action here as we've seen before. You write the action code as a method of any of the classes in the IB knows about. For example, the app delegate. For this particular example, in that particular class, it's the one that's making the IB known because we have it specified. So going back to the concept of the .h and the .m, we're going to specify the component, basically give it a label in the .h, and then in the .m we're going to actually give it the action, because the action is the implementation. So we can create the interface, which is the acknowledgement that we have a label out there, a text box out there. And then when we implement it, we're going to say, well, what happens in this text box? When the user clicks in there, do something. If the user changes the text, do something. If the text is empty, do something. You know, so we have all these different logic, and that's program specific in terms of what you want to do. So actions are in the implementation. So you click on the item, you open up the connection inspector or the inspector window. Under there you can actually see the selector, what actions are associated with it. In our case, we click on the GUI, we right mouse click on the GUI, and it pops up a little dark window that shows up a list of actions that are associated with a button, or a list of actions that are associated with a text field, etc. and so forth. So these are the older instructions for the older window view. So anyone who actually has the older version of Xcode can follow this actually, and this will add your components. Now it's actually easier. You don't have to. So I'm going to skip the stuff that's not relevant for the current version. So adding an action to the GUI item. To continue the concept, the process corresponds to the target action pattern, as we've seen. The target action pattern still exists, so we use it by writing the app without the IB. You can write the app without the IB. The action method must be written with one parameter of type ID. So the type ID is the generic type, so we usually say ID text field or something. So these are elementary steps for using the interface builder. The ID type, which we're going to see a lot, is nothing more than a pointer type or reference type to an object. The objects can be of any type. So usually we see this associated with the GUI components, because the GUI components are just components. We put them on there and then we specialize what they're going to be doing, stuff like that. Alright, last but not least, we've got protocols and properties. I saved this one for last because it's kind of the more confusing one. It's not as fun as the GUI stuff. And I sort of went through this kind of quickly, so stop me if you guys have questions, but we have a pretty small group, so it's pretty quiet, I hear. I don't hear any noises going on. What is a protocol? So this is a new concept introduced today. We have formal protocols. Formal protocol is a collection of method declarations that are defined independently. That word is independently here. It's misspelled. Of any class. So we have protocol 1, which is an NS object. Void, print, show, compute, and so this is a formal protocol using the app protocol to declare the protocol. We don't necessarily have to use protocols, but this is just an example of one, because sometimes you look at examples and it's going to use this. Kind of like a template. It's a collection of methods, basically, that aren't associated with any class. They're just methods. use this mostly more so in iPhone, iPad development versus regular application development, because in regular old Mac OS X application development, we're gonna create a class, and the class is gonna be inherited from another class. And we're really working with object orientation, and all of the methods are inside of these classes. Out here, we're just gonna create a it's almost like creating a function outside of any class, so which is essentially serving the purpose of an independent function or declaration of a method. And method is a function, by the way. Informal protocols, these are actually categories. And I'm going to talk about those later. So adopting a protocol. So protocol 1 can be adopted by any class. So interface student, protocol 1, which means the class student must implement the methods of the protocol 1 in its implementation. So what does that say? Well, Java people, you're looking at an interface. Well, protocol sort of is an interface, but it isn't. It can be used sort of like an interface. So if you say that this particular class must implement this protocol, that means the class basically has to have all the methods in it that are inside of the protocol, which is the same as a Java interface, if you think about it. But this doesn't have to be used inside of a class. You can actually implement the protocols without the class. It's independent. Failure to implement. If the class that adapts the protocol does not implement the methods in the protocol, the compiler will issue a warning. Yes, and for each one of them, it's the same thing as an interface. You don't implement it, then you're done. So what does that do? Well, basically, protocols serve the same purpose as interfaces in a lot of different ways. In fact, what they're essentially doing is setting a design pattern, almost. In this particular case, in this protocol example, we have a print, a show, and a compute. And these are methods, by the way. And this is a protocol, not an interface, and not an implementation. And we have the name, and we have NSObject because it's being inherited. This is old. This is just syntax. It's being inherited from. It's an NSObject type, is what this is. So it's a type of an object, the protocol. So as long as the adopted methods are not called, there will be no consequences for the running code. So you can actually sort of be, as long as, for example, you put the protocol in, you implemented it, but you didn't put anything in there. You just said, print out hello world, print out hello world, print out hello world for all of these methods, and these are the methods that you would actually have to implement. Then, as long as you're not using it, nothing's going to happen. Only problem is you put it in there and then all of a sudden it's used, and then you have this really strange behavior that happens because it's printing out hello world now or something, which may not necessarily be desirable. So checking for conformity. So during the running of the program, checking can be performed whether or not a given class or a given object conforms to the given protocol by checking. It is done in terms of using or checking the protocol. So it's done like this particular example below here. So PT is a pointer to an object. Protocol 1 is the pointer to a protocol. So PT conforms to protocol. You're running a method on the protocol. On the pointer to the protocol, PROT1. So the method call is going to basically come back and give you a true or a false. Does it conform or does it not conform, which means was it implemented or was it not implemented correctly. So the method returns true if the class of the object PT has adopted the protocol, and false otherwise. It does not check whether or not the methods of the protocol are implemented or not. It just checks if it has actually implemented it, or checks to see whether the methods themselves adopted the protocol successfully. So you can't really use this essentially to, well, the formality is that it's nice to make consistency among the objects, but it's not going to be strictly enforced. You can bypass the protocol. So, grouping of classes. So protocols allow the grouping of classes and objects according to the protocols they have implemented. So if this is a object group that is supposed to be for a particular UI view to perform a particular action, then it all has the same implementation of this particular IB action that has been implemented, hopefully, in each one of the classes. And it all conforms to a particular standard, which means you're essentially doing the same thing you are with an interface. Here. Giving the class some standard behavior, so everybody knows how to print, everybody knows how to view, everybody knows how to do particular behavior because they all have the same method. So you don't, if it belongs to a particular group, then you don't have to worry about the method names. You know, the methods are all the same because they're all using the same protocol. The reason why I'm showing this to you is because you'll never probably create a protocol, but every single one of the methods that you're running on existing classes in the NS library all conform to protocols because they all contain the same things. You can convert to this, convert to that. So you're running a bunch of methods, and you usually end up doing this with when you start using NS objects in iPhone applications. You're running a bunch of methods that are already predetermined. For example, alloc. You can run alloc on every single object. Oh, it's part of the protocol. Everybody's got an alloc. Well, there's a dealloc too. And then there's, you know, init and initializers. I think I talked about initializers last week or Monday in this class. You can write an initializer for a class object, and as long as it conforms with the protocol, as long as the protocol say, well, you have init, the name starts out with that, then, you know, every single object, when you run init on the object, it's going to start out, it's going to look for the method that starts out with that protocol that says it starts out with init and runs the right method. So basically it just sets a pattern or a set of rules. Protocols allow grouping of classes according to the protocols they have implemented. The groupings override hierarchical relationships as well, or they can. They don't have to. So in terms of declaring the protocols, we have property. This is where the property comes in. So declaration. So if a property is supposed to provide accessors for the instance variables, for example, float values, when declaring in the interface of the class. So as an example, if I said property float value, as an example, I could declare this property. What's a property? Well, I just went over this, but I'm going to hit this in a different way because this is a declared property that's part of the protocol of the object. So the word property is implementing. What does property do for us? Well, it automatically gives us setters and getters. Setters and getters. Well, that's a rule. It's a protocol on the class. It says when we declare a property, then we're going to have to declare. Also, we have to use synthesize. We use synthesize. So we use property in the .h, and we use synthesize in the .m. And this protocol that's been implemented on the object says automatically create the setters and getters for us. So what we've done is on every single object we use that follows this protocol, which is everybody in NS object follows this protocol, we have the definition of property. So we say property float value. Okay, well, float's the data type, value is the name of the data member. This is of the class that we've decided we're going to use. We're going to call it value. So they provide a shortcut for defining getters and setter methods for the instance variables of that particular class. So we don't have to create get value, set value, and we do this for everyone. And this is actually for you guys, for you who was in the Objective-C earlier one, we didn't do anything here. It didn't set the read write. This is simplified. So we didn't set the access. We could set what the protocol is actually going to do. We can actually set with a method call that says run this method but set read and write, which means set the setter and the getter instead of, you know, here if by default it's going to do both. So that's going to actually give us the setters, and I'm assuming you guys know what setters and getters are. When you set the property, you set the value that's associated with value, and you get the value from their class object. So they serve only as convenience to programmers. They are not essential to a feature of the language itself. Everything can be done without them, with basic Objective-C features alone. They work with conjunction with the synthesize directive. So this one goes into the .h, this one goes into the .implementation file. You just put synthesize value, comma, name, comma, age, comma, everything, and it gives you the implementation for you. That's actually an example of a built-in protocol for a group of classes, believe it or not, which conforms to these methods. And inside this protocol, there's something that's called property, there's something that's called synthesize. that's used on the object to make this behavior work. It's a library call that prevents you from having to write setters and getters. Setters set a property. Getters get the value of the property. Properties are data members that are part of the class object that belong to the class. So we can declare property specifics. So if the programmer sticks to the defaults, then there's convenience in programming the accessor methods. The name of the declared property is the name of the instance variable. So the declared property XYZ would be the name of the variable XYZ. The creator accessor methods are XYZ for the getters and set XYZ for the setters. So you can actually run automatically set value or just return value, which we actually haven't seen yet in the other class. So if you're confused about the property and the synthesize, watch the video from the Objective-C course, and then the one on Monday is going to actually implement that, so you can see how it works together. And we're going to see it, but we're going to focus primarily on the iPhone emphasis of it. Used a lot, actually. Properties are used all the time because it's a shortcut method. It's why write it. So let's see. So the accessors here get the set, which comes from the set and the get. Okay, so that's like probably, you know, not a bad way to create your accessors and your modifiers and your other languages as well. People always call it set this, get this, in terms of what you're doing. Overriding defaults. So all defaults for properties can be overwritten as well. The name of the property can be different than the instance variables. Okay, the name of the getters and the setters can be set as desired. You can set the name to anything you want, or you can just use the defaults. Most people would just use defaults. Properties can be set to do either assign or retain or copy in the setter method as well. Because when we set something, we can retain what was there, we can release it, get rid of it, or we can assign it and overwrite what was there before. This has to do with the way that the memory is going to be managed for the particular data member that we're actually setting. The synthesize directive tells the instance variables to declare the property it refers to. So synthesize actually does the work or the implementation of the assignment of those values, and you know the basic sets the ability to work with the variables or the interface to the variables. All right. So that one, actually I went through this kind of fast, but that was what we were supposed to cover tonight. You guys want more, or should we stay on track? I can go longer. There's nobody here tonight. Why isn't there anybody here tonight? Oh, then I'll give you a break. We can end early tonight, because I think we've been keeping you sort of on the late side for a couple of nights. So, but that was the material that I needed to cover. So, digest it. Go through, pick up, read through the Objective-C. If you haven't taken the Objective-C course, I highly recommend going back through and looking at some of those videos, especially the one from the last couple of meetings. You'll get to a certain point where you won't have to watch them anymore. But the concept of the class files is going to be important because we're going to take a huge jump soon. We're going to go into writing different applications and using features. And unfortunately, there's too much to do and teach you Objective-C at the same time. So right now there's a little bit of slack, so you can kind of catch up and get familiar with Objective-C. I do have some basic Objective-C stuff I'm probably going to hit you with next time, but hopefully you'll already be prepared for that. So, all right, we'll leave early tonight, and I will see you next Monday.